I'm Dr.B Ravi Chandra, and I'm here to discuss about the related topic, which is linear filtering method using DFT and IFDFT, followed by overlap save and overlap add method. In the last lecture, we had discussed about the different types of systems and properties of discrete Fourier transform. Some different types of properties we have discussed, and we have proved the statements of that each property, and some problems related to that properties also we have discussed. Now same the continuation for that, today in this lecture we are going to discuss about the linear filtering method using DFT and IDFT. Today we are going to discuss about some contents related to linear filtering using DFT and IDFT. Why do we use overlap add and overlap save methods in DSP? What are the steps in the overlap save methods, and some related problems of that overlap save method, and followed by the what are the steps that involves in the overlap add method, and some problem related to that overlap add method, and what are the difference between both the overlap save and overlap add method. It is very important when we come to the digital signal processing. First, starting with the linear filtering using DFT and IDFT. As usually, we have discussed some problems related to this topic in the last lecture, but once again I need to discuss some block diagrams related to this linear filtering using DFT and IDFT. So these are the equations which we are familiar with. Y of n is equal to summation n is equal to minus infinity to infinity h of k x of n minus k, and Fourier transform will get y of omega is equal to, if we do the Fourier transform for that by the convolutional property, so Fourier transform of x1 convolute to x2, what we are going to get, that is capital X1 into x2. So from the above property, the second equation, this equation we can express that in the form of y of omega is equal to h of omega into x of omega. By considering this particular convolutional property, this second equation can be represented as y of omega is equal to the impulse response, that is h of k on Fourier transform will be converted into h of omega, and x of n minus k on Fourier transform it will be converted into x of omega. That is, overall I can say that y of omega is equal to impulse response h of omega into x of omega. So based on the particular, we will see some different types of block related to this. So simply if we consider the linear convolution, how the y of n will be obtained. So this is the simple basic block diagram where I am giving the x of n with a lengthy sequence, some lengthy sequence as an input to the LTI system, linear time invariant system, and which that impulse response of that system is h of n with the length of capital M. Okay, so I am giving x of n with the length of capital L, which is given to the linear time invariant system, which its impulse response is h of n, and the length of this impulse response is capital M. So what I'm going to get, I'm going to get the total input, that is the output of this particular y of n is equal to the output of the x of n into h of n. And what will be this output? The output of y of n is equal to the multiplication of x of n into h of n, and the length of that particular will be L plus m minus 1. This is the length of the output obtained at the output side. So this is the simple block diagram when we consider only the linear convolution. Now coming, if we consider the linear filtering by using the DFT and IFDFT, what will be the y of n? What the I of n will be obtained? For that you can see this basic block diagram. See here, similarly I am giving here for the first input as x of n is equal to as an input with the length of capital L, which is given to the input, and here I am doing m minus 1 zeros. That is, what is m minus 1? M is nothing but the length of the impulse sequence. Here we need to balance these both length of the sequences for x of n and h of n. For that, first what I am doing, I am giving as an input x of n with the length capital L. While I am giving, I need to balance the length of the sequence. That's why what I am doing, I am adding m minus 1 zeros. M minus 1 zeros for the input what I have given as x of n. Then what I am going to get, the length of total will be n is equal to L plus m minus 1. Here finally after zero padding, the final equation what I am going to get is n point DFT, that is x of n will be converted into capital X of k So here one input I have given. Similarly, I am taken h of n with the length of capital M, and I told you that the sequence should be balanced here. For that, what I am doing, I am adding the L minus 1 0 padding. L means length of the input sequence, x of n minus 1, whatever the value I am going to get, that many zeros are added to the input sequence h of n. So that for that same, you can see here, the length will be get equal, n is equal to L plus m minus 1, and here also you can see n is equal to L plus n minus 1. So at this stage, the length of the both sequence x of n and h of n will get equal. Then what happens? It will be converted into endpoint DFT, where that h of n will be h of k. Now here, after forming this x of k into h of k, I am multiplying both DFTs. That is x of k into h of k. What I am going to get here? Y of k is equal to h of k multiplying x of k. Okay. So I got y of k is equal to x of k multiplying x of k with h of k. So what I formed is y of n. Now here I am doing the inverse discrete Fourier transform. You can see this endpoint y of k is inversely discrete Fourier transform, where that y of k is converted into y of n with the length capital N is equal to L plus m minus 1. You can see the length both here. The output length what I am going to get will be equal to the length what I have converted here. N is equal to L plus m minus 1. So the conclusion of this particular basic diagram, that is, by using the DFT and IDFT, I can obtain this y of n by multiplying x of n with h of n. See here, x of n I have multiplied here. That means after DFT, I have got x of k, y of n. After DFT, it was converted to h of k, and both are multiplied, where I got capital Y of k. Now once again I need to reconvert that thing. For that I have taken inverse discrete Fourier transform of y of k, where it is converted into y of n. So this is the simple basic block diagram of the linear convolution using both DFT and IDFT. Fine. Now third one, linear convolution using circular convolution. In the last lecture we have seen some problems related to this linear convolution using circular convolution. Of course, we will recall that particular problem in the next upcoming slides. So we will see the basic block diagram. What happens here? You will see here the length of x of n is capital L. So the length of x of n is capital L, and the length of h of n is capital M. So this length is given to the input as an input. But I told you that here what we are going to do, we need to balance the length of the sequence, both x of n and h of n. For that we are adding m minus 1. We are adding m minus 1. M is the length of the h of n. So m minus 1 zeros is added to the x of n. And for this also we are adding L minus 1. What is L? L is the length of the x of n. L minus 1 zeros are added. So both zero padding is converted, done here. So after padding here, the both length n is equal to L plus m minus 1, n is equal to L plus n minus 1. You can see both length of the x of n and h of n will be equalized here. Okay. After that, we are giving it to the endpoint circular convolution. These two converted x of n into y of n is given to the endpoint circular convolution. Here, the circular convolution process will happen. So after this circular convolution, we are going to get the value of y of n, that is n is equal to L plus m minus 1 length. So if you observe this diagram with the previous diagram, this one, y of n obtained through DFT, here same thing happened, but instead of this particular DFT and IDFT, what happens there? Their circular convolution has been done. That means their linear convolution by using the circular convolution, here linear convolution by using the DFT and IDFT. These are the basic differences between the convolution when happens when we are using the DFT and IDFT, and convolution when we are using the circular convolution. We will get the same answer. If we do the linear convolution with using the DFT and IDFT, the answer will be same when we use the linear convolution by using the circular convolution, which we have seen, and we will see that with the help of one following example. Fine. By considering one example, I am here taking one example related to this linear convolution. Already we have discussed this in the previous lecture. Just we will recall the thing what happens. So it will be helpful for the previous block diagrams. See here, they have given the input sequence x of n and h of n, and he has to perform this in linear convolution and circular convolution, and linear convolution using circular convolution. Fine. So here first h of n is equal to, you can see the length of h of n, capital M is equal to 3 and length of x of n, capital L, is equal to 4. First we need to find out this thing. So here we need to make the length should be equal. So for that, capital N is equal to L plus M minus 1. That L means 4 plus 3 minus 1. So the total length is 6. So after doing the simple linear convolution, see here, this factor is first multiplied with all the factors, that is 1 1 is 1, 3, 2, 1. This factor is again multiplied with all the factors, that is 1, 3, 2, 1. And this one is multiplied to all the factors, that is 1, 3, 2, 1. So after multiplying and adding, the final answer what I am going to get, y of n is equal to 1, 3, 6, 6, 4, 1. You can see here 3, 3, 6. How much? 6. And you can see the length. Final length, what should I get? I should get the length of y of n will be 6. The length of that y of n should be 6. This is the linear convolution. Simply we are using the linear convolution for the x of n and y of n. Now second is asked to find out the same thing by using the circular convolution. See here. So first what we have to do, we need to do the zero padding in this circular convolution. See here, we got the value of x of n is equal to 4. The length of x of n is equal to 4, but here the length of h of n is only 3. If you see the previous question, we have only the length of the h of n L is equal to only 3. So what we have to do, we need to do the zero padding. So for that, how many zeros should we add? We need to balance this thing now. That's why 1, 2, 3, 4. 4 means here I got only 3. So 1 0 is added here. So that is zero padding and done. So the length of this both has been made equal. Now what I am going to do, I have taken the x of n. This is the x of n sequence, that is 1, 2, 3, 1. I am writing it vertically. Now again this one is shifted to top and same 1, 1, 2, 3. Again this 3 is shifted to top, 3, 1, 1, 2. Again this 2 is shifted to top. Like this, a matrix representation has been done here with the help of x of n, and this x of n is multiplied with h of n, that is 1 1 1 0. So what I got here is y of n is equal to 5 4 6 6. This is the linear convolution using the circular convolution. Now previously we got the answer, that is 1 3 6 6 4 1 with the help of linear convolution. So this linear convolution can be converted into circular convolution and we can frame this, we can get the same answer. How we can get? Just multiplying the first term with last but one term. See here, the first term is added to the last but one term, that is 4 plus 1, and the second term is multiplied with the last term, that is 3 plus 1. So first term is added to the last but one term. What I got? 1 plus 4 is equal to 5 I got, and the second term is added to the last term, that is 3 plus 1, I got 4, and the remaining terms as it is I have written here. So if you see that 5 4 6 6, that is the linear convolution. If we use the circular convolution, the answer will be get same. Y of n is equal to 5 4 6 6, and here also if we converted that, the answer will become same, 5 4 6 6. Okay, so this is the second pattern by using linear convolution using the circular convolution. The third thing, linear convolution using circular convolution. Here also you can, first we know the value of x of n and we know the value of y of n. What we need to do? First we need to do the zero padding. See here, m minus 1, that is 3 minus 1, that means m value, the length of x of n is m. M is equal to 3 and L is equal to 4. Now how many zeros should be added to the x of n? M minus 1, that is 3 minus 1 zeros, that is 2 zeros is added to the x of n, and we know that value of x of n is equal to 1, 2, 3, 1, and how many zeros should I add here? 2 zeros, that is 0, comma 0. Now similarly, how many zeros should be added to the h of n? That is L minus 1. What is L? 4. 4 minus 1, 3. That is 3 zeros is added to the h of n. And we know the value of h of n is 1, comma 1, comma 1, which is given in the question. And how many zeros should I add? I need to add 1, 2, 3. So 3 zeros I have added. Now you can see the length. Here 3, 3, 6. Here also 6. So we can see here both the length of the sequence has been made balanced. Now here 6, 6. Again, the matrix representation x of n I have taken and have written that in the matrix form 1 2 3 1 0 0 1 2 3 1 0 0. Again this 0 is shifted to upside. Now written the remaining things. Again the form last 0 is shifted to top. Again the last shift is shifted to first. 3 is shifted to first. Next 2 is shifted to first. Like this, one matrix representation is formed here, and this matrix representation is multiplied with h of n, that is 1 1 1 0 0. If we do the matrix representation, we are going to get the value y of n is equal to 1 3 6 6 4 1. So see here, linear convolution using circular convolution, what we got? We got the same thing. By using on the linear convolution, what we got here? 1 3 6 6 4 1. Similarly, by using the linear convolution using circular convolution, I got the same answer. If you check this particular problem with the previous block diagrams, using the circular convolution and simply by doing the linear convolution, the answer will be same. Okay, by using only the linear convolution, I got the same answer from the first diagram, and by using the linear convolution using circular convolution, that is third diagram, I got the same answer. Y of n is equal to 1 3 6 6 4 1. Now one more thing, one diagram we need to check here is linear convolution using DFT and IDFT. The second diagram what we have discussed, that is linear convolution using DFT and IDFT. For that, one problem I have taken, what he asked, find the linear convolution of the sequence x of n and y of h of n using DFT. So what is the value he has taken? X of n is equal to 1 comma 2 and h of n is equal to 2 comma 1. Now if you see here, to do this linear convolution, what happens? It produces only 3 samples. So because of these small sequences, what happens here? Some aliasing effect may be occur here. So for that, what I am going to do means, just I am converting these 2 samples into 3 sample sequence. That is what I am doing. I am adding 1 0 to the each sequence. See here, 1 comma 2 comma 1 comma 2 comma 0. That is 1 0 is added here and 1 0 is added here, so that the length of the 2 sequences has been converted from 2 to 3. So here the length will be 3 and here the length will be 4. Why I have done means, to avoid some aliasing effect, that 2 sequences has been converted into 3 sequence. Now what I am doing, I am by using the DFT, I am going to find out the value of the 3-point DFT sequence x of n. For that, we know that this is the generalized equation, capital X of k is equal to summation n is equal to 0 to 2 x of n e power minus j 2 pi by 3 kn. Now how many the length we have here? 3 lengths. N is equal to 3 na, so n is equal to 0 to 2, capital N is equal to 3 value 2 pi by 3 kn. So I have expanded this, that is for n is equal to 0, 1 and 2. So by expanding this, one equation has been formed here, that is capital X of k is equal to 1 plus 2 e power minus j 2 pi by 3 k. So in this, what we have to do, we need to substitute the values of k, that is for k is equal to 0, for k is equal to 1, for k is equal to 2. By substituting that, we will get the value. If I substitute the k is equal to 0 in this obtained equation, what I got here, the value k is equal to 0, I got 3, and for k is equal to 1, I got the value j minus j 1.732, and similarly for k is equal to 2, I got the value j 1.732. I got total 3 values. Now what values I have got here? X of k values. Now I need to find out the value of h of k. Similarly, I consider the equation h of k is equal to n is equal to 0 to 2 h of n e power minus j 2 pi, capital means 3 value and nk. Similarly, I expanded this particular summation h of 0, h of 1, h of 2, and after simplification, one equation is formed, that is 2 plus e power minus j 2 pi by 3 into k. Same pattern. What I am going to do, I am substituting the 3 values. For k is equal to 0 in h of k, for k is equal to 1 in h of k, and for k is equal to 2 in h of k. If I do that thing, I got 3 values, 3, 1.5 minus j 0.866, and for k is equal to 2, 1.5 plus j 0.866. So I got 3 values of x of k, which is the input sequence, and I got the 3 values of h of k, which is the impulse response. After getting this, what we need to do? We have to do the multiplication. Y of k is equal to h of x of k into h of k. So for k is equal to 0, I got the value of x of 0 is equal to 3 and h of 0 is equal to 3. So what is the first value I got? 9. Similarly, when k is equal to 1, what is the value of y of n? If I multiply the x of n and h of n value, I got this thing. And finally, for k is equal to 2, same y of 2 value is equal to, I got this thing. That means finally, I got y of k is equal to, this is the sequence. That is, after doing the DFT, y of n, after doing the DFT for x of k and h of k, I got the value of y of k. Now, what should we do? We need to reconvert this y of k into y of n. For that, I need to take the IDFT. Now, I am using here IDFT. Up to here, I used DFT for the linear convolution. Now, I need to reconvert that y of k into y of n. For that, the sequence y of k is done with the help of IDFT. So, I am using IDFT. So, what is the equation? Generalized equation y of n is equal to 1 by n summation k is equal to 0 to n minus 1 y of k e power j 2 pi by n into k. So, for all the values n is equal to 0, 1, 2, so on, n minus 1. What is the n value here? 3. So, 3 minus 1 means 2 values, that is 0, 1, 2. So, if you substitute all the values for n is equal to 3, n is equal to 3 and y of k means these total values is substituted here. So, 1 by 3, if I expand this summation, y of 0 into e power 0 plus y of n into e power j 2 pi by 3 into n plus y of 2 into e power j 4 pi by 3 into n. For how many values it is? For n is equal to 0, 1, 2 values. So, finally, if you substitute same, if you substitute n is equal to 0, n is equal to 1 and n is equal to 2, what I am going to get? For n is equal to 0, if I substitute all the value for n is equal to 0, y of 0 is equal to 2 I am going to get. And if I substitute n is equal to 1, the total value y of n is equal to 5. And if we substitute n is equal to 2, I am going to the value, final value y is equal to, y of 2 is equal to capital 2. That is, this is the finalized sequence y of n is equal to 2, 5, 2 is the final sequence y of n. That means, first I have done DFT. After getting the equations of DFT, then again I have done that DFT y of k, IDFT for y of k, where that is converted into y of n, and the finalized answer what I got here is 2, 5, 2. Now, we will get some doubt here whether the formed problem is correct or not. For this topic, which is simplification, that means whether the formed equation, whether the formed answer is correct or not, with the help of this particular simplification, we can confirm that the formed answer is correct or not. For that, what I have taken, so on the x-axis, on the vertical axis, I have written the value 1 and 2, and on x-axis same, I have written the value 1, 2, sequences. Fine. Now, 2 1s are 2, 2 2s are 4. Now, 1 1s are 1, 1 2s are 2. So, like this, I have drawn the dotted lines. So, I have drawn the dotted lines. Now, 2 plus, so what is the value here? First value is 2. First value is 2. Next, first in this first column, what I got? I got the value 2. So 2 I have written here. Now in this particular cell, what is the value? 4 plus 1. 4 plus 1 means 5. Now in this particular cell, I got only one value 2. So the answer what we got in the previous thing is correct. So that means with the help of this particular tabular column, we can confirm whether the formed answer is correct or not. So fine. Now same, this another thing, find the linear convolution of the sequences x of n and h of n. So DFT, by using DFT, got x of n he is given and h of n also he has given. So if you see here, x of n is equal to 1 0 2 0 and y of n is equal to 1 1 0. How many zeros has added? Here 1 0 is added for the x of n and 2 zeros is added for the h of n to equalize the sequences of the both sequence x of n and y of h of n. Same. Now I need to obtain the value for that x of n, DFT of x of n. So I have taken the equation and we know that capital N is equal to 3. We know that the length what we got here is L plus M minus 1, that is 4. 4, capital N is equal to 4. So N is equal to 0 to N minus 1 means 3, x of n e power minus j by 2 pi by 4. 4 is nothing but the capital N. So I have expanded this summation, x of 0, x of 1, x of 2 and x of 3. So same. we need to substitute how many values? 3 values. That is k is equal to 0, 1, 2, 3. So for k is equal to 0, k is equal to 1, k is equal to 2, k is equal to 3. If I substitute all the 0, 1, 2 values in this formed equation, for k is equal to 0, 1 plus 2 e power 0. So I got value 3. For k is equal to 1, I got the value minus 1. For k is equal to 2, I got the value 3. And for k is equal to 3, I got the value minus 1. That is capital X of k. If I do X of k, that is DFT of X of n, I got X of k. Similarly, we need to do the same thing for the impulse response H of n, same. We need to expand the expression and finally we will get one equation for that H of n. So in this H of k, we need to substitute the value of k is equal to 0, k is equal to 1, k is equal to 2 and k is equal to 3. So finally we will get the values for all the 4 samples. So here you can see 4 x of k and 4 h of n sequences has been formed. Now what we need to do? We need to do that y of k is equal to x of k into h of k for all the values 0, 1, 2, 3. So we know the values what is obtained. X of k is the values and y of k is the values. Sorry, h of k is the values. If we multiply by those two things, this is the final value of y of k. So this is the final value of y of k. Now what is the agenda? We need to reconstruct that y of k. For that the sequence y of n should be obtained. So for that what we are going to do? We are going to do IDFT for obtained y of k. So for this y of k, I am doing the inverse discrete Fourier transform where I am going to get y of n. Now same, we know the equation of IDFT, 1 by n summation k is equal to 0 to n minus 1 y of k e power j 2 pi by n small nk. Same, how many values we should do? We should substitute here. K is equal to 0 to 3. I have expanded the equation and after expanding the equation, for n is equal to 0, I will get the one value. For n is equal to 1, for n is equal to 2 and for n is equal to 3. Totally if we do the values, that finally y of k is converted into y of n, which is nothing but x of n convolute h of n, that is 1, 1, 2, 2 is the finalized answer. So this is the linear convolution, and to confirm that whether the obtained answer is correct or not, just see here h of n on the vertical axis and x of n on the horizontal axis. So 1 ones are 1, so one value I got here. Now 1 ones are 1, 1 0 0. So if I add these two things, 1 plus 0, 1 I got. Now second 1 here, if we come here 1 0 0 and 1 2s are 2. So if we add these things, 0 plus 2 I got 2 and finally 2 value I got 2. That is 1 1s are 1, 1 0 0 0, this is the first thing. Now 1 1s are 1, 1 0 0, 1 2s are 2. Two things I have added here and I formatted this thing like this. So in the first cell I got only 1, so 1 is the answer. In the second cell I got 0 plus 1, that is 1 I got. In the third cell I got 0 plus 2, that is 2 is the value, and in final cell I got only 2 values, so 2 is the answer. So by this small simplification tabular column method, we can confirm that the answer what we got by using the linear convolution using DFT and IDFT, the answer is correct. Fine. So this is the basic, this is the thing how we are going to use the linear convolution by using the circular convolution and also by using the DFT and IDFT. Now coming here, so up to now we have seen the sequences which is very small in length, that is 3, 4, 5. So what happens if the sequence is length? The length of the sequence is more. So for that some different types of filtering methods has been invented here. Why means if you see here in practical application, we have often come across linear filtering of long data sequence. This is the term you need to keep it in mind. What happens if I get a long data sequences? So it will be somewhat difficult for the DFT, which involves some operations on the blocks of the data. So for that, this block size of data should be minimized because digital processor have a limited memory. So because of this particular thing, this block data, that is these long data sequences should be minimized. Okay, so these should be minimized. Why? Because the processor what we are using will have a limited memory. So for this kind of criteria, we are introducing two methods. One is overlap save method and another one is overlap add method. These two methods are used to solve the sequences which is in long data sequences in the linear filtering. Okay, so we will see the two methods in detail and with a one examples each. So what is overlap save method? What are the process? What are the steps involved in the overlap save method? See here, similarly we know that let x of n be the longer sequence. So let x of n be the longer sequence of the length capital N and h of n be a smaller sequence of capital length capital N. Now here what we need to do, he's telling that x of n length is very long. X of length is very long when compare it to the h of n. H of length is small, let it be 3. So if you see the length, it is very long. So for this what he is doing, his x of n is segmented into L number of blocks. That means this length is segmented into L number of blocks. So for that we need to select the value capital N is equal to 2 power m. If the n value is given, not a problem. If the n value is not given, so we need to use this formula, that is capital N is equal to 2 power m. M is the length of the sequence x of n. Okay. Now you can see here, this is the lengthy sequence, x of n length sequence. What I have done here first, I have converted this length of sequence into L number of blocks. See, L samples. Fine. Now second value, what we done here, n is equal to 2 power n. Fine. Now here, if I subdivided all the sequences into, we will get x1 of n, x2 of n, x3 of n, so on. How many blocks we are going to divide? That many block sequences will be formed. Now in the next step, the length of h of n is made n. The length of the h of n is made n by padding L minus 1 zeros. Okay, by padding L minus 1 zeros. That is, for example, see here, what he is saying, if I want to do the length of h of n, so it should be made, h of n length should be equal to length of n. So what is the value we got here? If we go to the previous slide, if I get the value of n is equal to 6, same, this h of n length should also be made capital N. How we are going to do that? We are going to do that by adding the zeros, that is padding, zero padding. How we are doing that? N is equal to m plus L minus 1. Why? Because we know the value of m, L. So with the help of this, L minus zeros are added to the h of n so that it is made equal to the value capital N. So how we are going to do that? H of 0, h of 1, h of 2, h of 3 is the length of the sequence. So on, how many zeros I am going to add? I am going to add L minus 1 zeros. If I do this thing, it will be equal to the length of the capital N. Now next what happens? How the sequences are subdivided. If you see previously, after subdividing all the x of n in L samples, x1 of n, x2 of n, x3 of n, like this we will get. So how we are going to subdivide means, now first one, x of n is equal to 0. How many zeros? It is L minus 1 zeros. So zeros, then x of 0, x of 1, so on, x of L minus 1. It is first sample. Now second sequence, x2 of n is equal to, what we are going to do? See here, x of L minus m plus 1, that is m minus 1 samples of x1 of n. L minus 1 samples of x1 of n is added to here. I think you are getting the point. First what I am adding here in x2 of n, in x2 of n, the first samples are nothing but m minus 1 samples of the x1 of n. Here m minus 1 samples, what here? This one. So these m minus 1 samples are added in the first term, remaining next the same thing. And finally for same thing, x3 of n also, the last two samples, m minus 1 samples of x2 of n is added to the first, remaining x2 of L, x2 of L plus 1, like this. Like this we are going to dividing the sequence. So now finally, after getting all the sequences, here we will get the value of h1 of k, and here we are going to get value of x of k, x1 of k, h2 of k, and similarly x3 of k. By getting all these values, how many subdivisions happens? That many y1 of k's values are going to calculate. For that, we are using the linear convolution. Y1 of k is equal to x1 of k into h1 of k. So x1 of k into h1 of k. If we get three values, we are going to get how many y-k's? That is y1 of k, y2 of k, and y3 of k. So depending upon the samples, these many linear convolutions are going to calculate. For calculate after getting, so finally in the sixth step, what we are going to do? how many samples we get, y1 of 2, y2 of n, y3 of n, so on, are discarded and remaining samples are fitted one after the other to get the final sequence. So you can see in this. This is the first sequence y1 of n I got, second sequence y2 of n, third sequence y3 of n. Now what I am going to do here, m-1 samples are discarded. That is, for example, m is equal to 3. So 3 minus 1 means 2. That is, 2 samples are discarded in front of the y of n. Here also 2 samples are discarded in front of the y of 2. In this also 2 samples are discarded in front of the y of 3. Remaining samples I am fitting here. y1 of n, remaining samples, y2 of n, remaining samples, y3 of n, remaining samples. Like this, finally I am going to get the value of y of n. It's very simple. If you see this with the help of one diagram, you will get a clarity what is the process we have studied up to now. So better we'll go with one example. Now what is asking, find y of n for h of n is equal to 111 and x of n is equal to, it's a very lengthy sequence. You can see the length of the sequence. Up to now we have not seen this kind of sequence, length sequence. We have seen only up to 1, 2 and 3, maximum 4. But you can see here nearly 9 to 10 length of sequence we have taken. So for that only we are using first method, which is overlap save method. Now see here. What we have done, we know the value of h of n length, capital M is equal to 3. So how many sequences here? Capital M is equal to 3. And if you observe in this question, we don't know the value of capital N. And I told you that if we don't know the value of capital N is equal to 2 power m. So what is m we know? We know the length of the m, 3. So 2 power 3 is equal to 8. So what should be the length? Capital N is equal to 8. This you need to keep it in mind. Now, we have to find out the value of L. Why? As I told you, h of n is equal to, by adding L minus 1 zeros. So L minus 1 zeros means, just consider this formula. N is equal to m plus L minus 1. So we don't know the value of L. So for that, we just 8 is equal to, so n is equal to 8 is equal to m value 3 plus L minus 1. That is 8 is equal to 2 plus L and L is equal to 6. So now here we got the value of length, capital L is equal to 6. So, how many values should I add here? So how many values should I add here? I need to add L minus 1 zeros. What is L? 6. 6 minus 1, that is 5 zeros is added for here. So see here, 1, 2, 3, 4, 5. 5 zeros is added to the sequence h of n. So this is the h of n sequence what I got in the second step. Third step, we told that the x of n, this total x of n it should be subdivided. Now how we are going to subdivide? Let's see here. What is the value of L I got here? I got the value of L is equal to 6. Now first I need to take the value of 6 sequences. These 6 sequences I am taking. See here, first I am writing 1, 2, 3, 4, 5, 6. 6 sequences I have written here. Why? Because capital L is equal to 6 I have written. So for this, I told you m minus 1 zeros should be added in front of the x1 of n. What is m here? 3. So 3 minus 1 is equal to 2. 2 zeros is added in front of the x1 of n. That means 0, 0 and the remaining sequences I have written. Total 1, 2, 3, 4, 5, 6, 7, 8. So 8 is the sequence I got here. Fine. Now again remaining these terms is there now. So what are the remaining? 0, 1, 2, 1. That is 4 sequences I got here. So first what I have done? 4 sequences I have written here. That is 0, 1, 2, 1. First I have written 4 sequences here. Just listen carefully. First I have written the remaining terms here. That is 0, 1, 2, 1. In the steps we told that m minus 1 samples of the last sequence and x1 of n. That means x1 of n last m minus 1 terms. That is m minus 1 means, what is m minus 1? 2. So these 2 sequences are added for the first. I think you are getting. That is m minus 1. That is 3 minus 1, 2. 2 samples of the x1 of n last. 2 last samples of x1 of n is added to the first of x2 of n. And the remaining you need to see. 1, 2, 3, 4, 5, 6. So how many still I need to get? I need to get still 2 more. That is why? Because the length should be equal to 8. So up to now I got 6. So for that I am adding remaining terms zeros. So here if you see, x2 of n and x1 of n are balanced in the length 8 and 8. So and here also you can see 3, 3, 6, 7, 8. So totally whatever if you are going to do, that all the length should be equal to h of n is equal to x1 of k, x1 of n is equal to x2 of n is equal to, should be equal to the length capital N. What is the value we are going to get? That sequence should be equal. Here also 8, this one is 8 and this one is 8. Clear? Now we got all the 3 sequences. Now fourth step, we need to multiply, that is by using the linear convolution. How many sequences we need to find out? Why? Because x2 sequences we have to find, y1 of n and y2 of n. Why? Because we have divided the sequences 2. If I have divided the subsequences, 2 sequences have been formed, x1 of n and x2 of n. Now, so for that I need to find out the value of y of n and y2 of n. Similarly, y1 of n is equal to x1 of n into h1 of n. We know the sequence y of n, so we have written this thing, and 2 is gone first. Again I have written this, 3 is gone first. I have again written this down, 1 is gone first. Like this, the total x1 of k is matrixly represented in the form of matrix. So overall I got the matrix representation of x1 of n, and this is multiplied with h of n. We know the value of h of n. After multiplying, this is the sequence y1 of n I got. Similarly for the same, I am taking the x2 of n sequences. x2 of n sequences, I have framed the matrix representation similar to thing what I have done in the above. So after framing this matrix representation, this x2 of n is multiplied with h of n, h1 of n, so that I got the equation sequence 3, 5, 5, 3, 3, 4, 3, 1. Now these are the 2 sequences I got here, and final step what we have seen, we need to discard the m-1 samples. So m-1 samples are discarded in each sequences what we got. Samples should discard. So m-1 means 3 minus 1, that is 2 samples in the sequence should be discarded in both y1 of n and y2 of n. So what are the 2 samples here? 5, 2 are discarded, and here 3, 5 samples are discarded. Clear? Now what are the remaining? 322046. See here, 322046 in this 533431. 533431. So after discarding the m-1 samples in both sequences y1 of n and y2 of n, final answer what we are going to get, y of n is equal to 322046, 533431. So this is the overlap save method, how we are going to used for the long data sequence. If it is given for x of n is a long data sequence, how we are going to subdividing that sequence and how we get the value of y of n. This is the overlap save method. Similarly, you can see the another example also. So we got h of n is equal to 3, and we got x of n is a long sequence, total 9 sequences is given, and what we are going to find, we are going to find out the value of L is equal to 9 value. If we need to find out with the help of m is equal to 3, where m is equal to length of h of n. So like this, we need to subdivide all the sequences. So how many sequences should I divide here? 3 sequences, that is 3, 3, 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9. First I have written in the first sequences, we need to find out we need to add m-1 samples. So m-1 means 3 minus 1, 2 zeros is added, and in the second subsequences m-1 sequences are added from the x1 of n. These 2 sequences are added here, and similarly last 2 sequences of x2 of n is added to the x3 of n, and similarly last 2 sequences of x3 of n is added to x of 4. So I got this one, and finally h of n is, we know the value of h of n, that is 1, 2, 3. How many zeros should we add? 3, 3, 2, 5. That is, here we got only 3, we need to add 0 to equalize this h of n with all the subsequences. And here we are done the How many sequences we need to find out? We need to find out y1 of n, y2 of n with the help of matrix representation, and y3 of n and y4 of n. Total 4 sequences we are going to get. So after getting the 4 sequences, see here, this is the y1 of n sequence, and this is the y2 of sequence, y3 of sequence, and y4 of sequences. I told you m-1 samples are discarded in each sequences. That is 3 minus 1. 2 samples in each sequences are discarded. So after discarding, remaining samples are written 1, 4, 10. That is 1, 4, 10, 16, 22, 28, 16, 22, 28, 34, 40, 46, 34, 40, 46, remaining 42, 27, 0. So 42, 27, 0. 3 sequences are added, and finally we are going to get the value of y of n. Like this, we can use this overlap save method to decrease the long length sequences if we are given, right? So this is another example. Same discarding, we are subdividing the x of n sequences. Totally we got 4 sequences. After getting the 4 sequences, we need to equalize the length of the sequence x of n and h of n. And after that, how many sequences we need to find out? 4 sequences, that is y of n, y of 2, y of 3 and y of 4. So with the help of say matrix representation, we found all the y of 1, y2 of n, y3 of n and y4 of n. And after getting all the things, we need to discard m-1 samples, and we know the value of m-1 means 3 minus 1, 2 samples are discarded and the remaining samples are written here. Okay, so these are all the some different types of examples which we can solve to reduce the samples length of the sequence x1 of n by using the overlap save method. Now the second one, which is overlap add method. So here also same, first we are going to take the longer length sequence x of n with the length capital L and h of n with the smaller length sequence capital N. Now here same, x of n is segmented into L number of blocks. See here, total x is subdivided into L number of blocks. Now if you see here, x1 of n is equal to m-1, x2 of n is equal to m-1, x3 of n is equal to m-1. That is, depends upon the length m, that many are subdivided into x1 of n, x2 of n and x3 of n. Now select the value. If we know the value of n, not a problem. If the n value is not given, same, n is equal to 2 power m. So after that, same again, the length of h of n is made sequence, which is same, which we have seen in the overlap save method. That is, h of n length should be equal to capital N. For that, what we are going to do, we are going to adding the L-1 0. So finally, we are going to get the h of n as this much sequence, which is equal to the length of the capital N. Now same, now here if you see here, the sequence which is very lengthy, that x of n is subdivided into subsequences x1 of n, x2 of n and x3 of n. Now what I am going to, here this is the small difference when we compare this with the overlap save method. There we have added m-1 zeros in the front side, and in the subsequence the last two m-1 samples is added to the first for the second sequences, and the last is n-2 m-1 samples is added to the first of the third sequence. So like that we have done in the overlap save method. But if you see here, x1 of n, how many zeros should be added here? m-1 zero will be added here for all these things. Second sequence, m-1 zeros is added at the last, and for the third sequence m-1 zero is added to the last. Just if you see here, this one where we have divided, after that m-1 zeros is added for all the last sequences. So that's what we have done here. Fine. And finally, after getting all the sequences, we need to calculate with the help of linear convolution y1 of k is equal to x1 of k into h1 of k. Now here the second difference when we compare this add method with the save method, there we have discarded the last first m-1 samples, but if you see here, add all m-1 samples of each output sequence to the first m-1 samples of the next output sequences. That means if you see this with the help of block diagram. So this is the first y1 of n. Fine. What is saying? First m-1 output sequence samples are, see here, first m-1 output sample sequence are added to the next sample sequence of the y2 of n, and first next m-1 samples of the y2 of n is added to the next samples of the y3 of n. Like this, how many samples we are going to get? That like that we need to add all the m-1 samples to the next upcoming succeeding output sequences. With this, finally we will frame the equation y of n like that, y1 of n, y2 of n, y3 of n, so on. Okay, so we will get a clarity if we see this with the help of one problem. Now take this, determine the output of linear FIR filter whose impulse response is h1 of n is equal to 1, 2, 3, and the input signal x1 of x of n is equal to total line sequence he has given by using the overlap add method. First, what we are going to do, we have taken the value x of n and h of n. So what is the length of the x of n? L is equal to 9 and the length of x of n is equal to 3. Now how many zeros should be added here? I told you, adding m-1 zeros, that is 3 minus 1 zeros, 2 zeros. 2 zeros are added at the end of each sequences. So 3, I have subdivided into 3, 3, 3, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. Fine. For that, how many zeros should I add? m-1 zeros. So what is m? 3. 3 minus 1 zeros. So 2 zeros I have added for the last two term. Now, if we compare that x subdivided sequences x of n with h of n, the length was somewhat different. That's why in this h of n also I have added 2. That is m-1 zeros, that is 0, 0, total 5 sequence. So now if we see all the sequences, all sequences are balanced with the length capital n is equal to 5. Now same circular convolution we are doing here, y1 of n is equal to x1 of n into h1 of n. Like that, how many we need to do? We need to do 3 sequences. First we are finding the value of y1 of n, same pattern, matrix representation, we will get the y1 of n, y2 of n and y3 of n. In the last step, I told you that last m-1 samples, that is 2. We know that m is equal to 3, 3 minus 1 is equal to 2 samples are added to the next succeeding output. 2 samples are added to the next succeeding output. Now this is the y1 of n output what I got, that is 1, 4, 10, 12, 9. In this, last 2 samples are added to the first 2 samples of the y2 of, that is 12 plus 12 and 9 is added to 4 plus 13. Similarly, in this y2 of n, last 2 samples are added to the next 2 samples for the y3 of n. So now if you see here 1, 4, 10, first I have written 1, 4, 10. Now if you see here 12 plus 4, 16, 9 plus 13, 22. I have added last 2 terms to the next succeeding. Now remaining 28, 27, 18. 28, remaining 28 I have written. Next samples are added to the next succeeding output, that is y3 of n. That is 27 plus 7, 34, 18 plus 22, 40. Then remaining term 46, 42, 27. I think you got the clarity how this reduction has been done with the help of a overlap add method. So this is the finalized answer what we are going to get by using the overlap add method. So this is another example you can see here. Same, subdivided all the sequences by adding m-1 zeros at the last term. So 3, 3, 3, remaining I got only 8. So see here 3 subdivided 3 and I subdivided 3. For each, how many zeros I have added? m-1, that is 3 minus 1, that is equal to 2 zeros is added for each sample. Last I got only 1 sequences, that is 8, and obviously how many remaining zeros should we add here? 1, 2, 3, 4. Why? Because here 5 sequences is there for all the x1 of n, x2 of n, x3 of n, and the remaining for 8 we need to add 4 zeros so that this length will be equal to the remaining subsequences. And 1 minus 3, 5, for this also I got added the 2 zeros. If you see, all the length of the sequences are equal. And same circular convolution, we found all the values y1, y2, y3 and y4. After getting that, adding the large 2 sequence to the next 2 sequences, adding last sequences, that is m-1 sequence to the next output sequence, adding last m-1 sequences to the next output sequence, and adding that finalized equation what we got here is y of n is equal to this one. So like this, we are going to use this both overlap add method and overlap save method for the reduction of longer length data sequences. So finally, you can see what is the difference between the overlap save method and overlap add method. In this method, the size of the input data block is n is equal to L plus m minus 1. In this the method, the size of the input data block is capital L only. This is the first difference. Each data block consists of the last m minus 1 data points. See here, each data block consists of last m minus 1 data points of the previous data block followed by L in U. I told you, last m minus 1 is added to the first sequences of the next sequence x2 of n, and the remaining will be new data L point. Here if you see, for the L block, m minus 1 zeros only added. We append m minus 1 zeros to the compute endpoint DFT. I think you got this m minus 1 is added in the first sequence. For the second sequence, m minus 1 samples of the first sequence is added to the second sequences in the front side. Similarly, m minus 1 samples of second sequence is added to the third sequence. Like this, it will happen here. But in this overlap add method, we just only add m minus 1 zeros to the sequences last to the each sequences. In each output block, m minus 1 points are corrupted due to aliasing. This is the main drawback which is present in the m minus point, as a circular convolution is employed. But in this, no corruption will be happen. Why? Because in this we are going to use the linear convolution by using the circular convolution. Here we are using only the circular convolution. For that purpose, some aliasing effect will be happen. But coming to this, using linear convolution using circular convolution, there will be no effect of the aliasing. And finally, to form the output sequence, the first m minus 1 data points are discarded. We will discard the first m minus 1 sequences in all the m minus 1 samples in all the sequences, where in this we are adding the m minus 1 sequence of the first to the next. So these are the four main difference between the overlap save method and overlap add method. So this is all about the introduction to the digital signal process, where in the last 3 lectures we have studied deeply about the what is signal, what are the different types of signals, and followed by what is the system, what are the different types of systems, discrete time signals, discrete time systems, and then we entered into the properties of the discrete Fourier transform. All about we have seen some 6 to 7, 8 properties of the discrete Fourier transform, and we solved some related problems also. And finally, with the help of this particular discrete Fourier transform problems, we just entered into the new technique which with the help of linear filtering, how these sequences can be reduced by using the DFT and IDFT, and linear convolution by using the circular convolution. And what happens if we get the length of the sequence is very long? For that, just now we have seen with the help of 2 methods, overlap add method and overlap save method, we can reduce that thing if the sequence of the input sequence x of n is given in a lengthy way. So this is all about the introduction to the digital signal processing. In the next lecture, we will discuss about the Fourier transform, where in this Fourier transform we will see introduction to the Fourier transform followed by the radix 2 Fourier transform. In the radix 2 Fourier transform, we will see 2 methods. One is decimation in time and decimation in frequency. Very important when we see upon the external exams as well as the gate level exams. This particular chapter is very important, so that this radix 2 DIT FFT and radix 2 DIF FFT, these 2 methods are very important, so that which we are going to discuss in the upcoming lecture. Thank you so much.